Hello and welcome to the next and possibly final episode of my tutorial series, Subtractive Synthesis on various synthesizers. So far I would say we have gone through all of the major sections of a synthesizer. We've discussed how to use those in isolation and building on top of one another to make various sounds. And in the last 2 to 3 episodes, I've been working on the Novation Peak, and I've been doing a little bit more complex sound design, diving into a few more of the features. In this episode, I'm going to dive into the final feature that I intend to cover, which is the modulation matrix for the effects. This isn't available on all synthesizers, but where it is available, it adds some interesting possibilities. So let's initialize the patch, and let's think about what we're going to do. I think what I'm going to do is make something that's a sort of droning sound, and then I'm going to use the effects and moreover modulating those effects to add a degree of movement to that sound. So first things first, let's see how it works if I just do a really detuned unison. Okay, so what's happened there is when I press the key, I have all 8 voices sounding in unison. At the moment, only one oscillator is turned up. But if I wanted, I could turn up all the oscillators. So what you hear now is a 24 oscillator unison. Obviously that's very loud. The unison isn't detuned, but we have a possibility here to add a sort of degree of divergence of the sound, meaning that the pitches will not all stay true, they will drift. So I guess you can hear that the sound is pretty powerful. These are all identical saw waves. I think saw wave is a bit strong for what we're doing here, so I think I might switch them all over to triangle waves. Okay, and now I'm going to adjust the shape of these a little bit, so probably something like this. I'm going to add quite a lot of shape adjustment to the first oscillator, so let me turn these down, and I'm going to turn unison off just so we can hear it more clearly. So as we turn it up higher, we get more and more of these harmonics coming in. Let's do the middle register one. And the upper register one. So let's bring some noise in as well, but the noise could do with some filtering down. Okay, so we have quite a lot of harmonic content there. We have some detune automatically happening, but I might add a little more. So I'm going to use the 12 dB filter. I usually prefer that for polyphonic sounds. A little resonance. I'm using bandpass here. I'm going to turn off filter tracking entirely. Okay, so let's go back into unison so we get the full sound. Do now is add a bit of drive to add a bit more texture here. So we have access to pre and post filter drive. We have an analog distortion circuit. modulating the filter with this oscillator. So I actually quite enjoyed the sound that I got there moving that. So the first change that I might make is I might add some of LFO2 to the pitch of oscillator 3. I might also add some LFO1 to the pitch of oscillator 2. So let's pick a couple of rates here. This is a drone sound, so I want these things to move relatively slowly. So mod matrix, oscillator 2 pitch, mod matrix, oscillator 3 pitch. I'm going to use the direct mode so I can hear. Now I'm going to add the 2 and LFO1, so now the LFOs are routed. So now I've latched the sound on. It's quite loud, so I'm going to turn it a little down a little temporarily. But now what we're going to do is to bring the effects into play. And what we're looking for is a way to add some sort of texture. I'm going to feed these effects through each other. And I think what I would like to do is go into the chorus, then into the reverb, and then into the delay. So in the effects section, I want to go chorus, then reverb, then delay, C to R to D. So let's experiment first with the chorus sound. So one thing to note about effects, there is only one effect section or set of effect units for the entire synthesizer. So when we come to modulating these effects, we can only modulate them reasonably with global sources. So though we have LFO 1 and 2 on the panel, we actually have two global LFOs. So one is set to a triangle. I set them to low rates. The next one, let's see. Maybe I'll set this one to a square wave, also not beat synced. So I don't have them tempo synced, and I have them at rates, let's put them closer, 11 and 13. I don't know exactly what that means. I can listen to them by using it to modulate pitch though, so we can get a sort of impression for how rapidly this modulation is moving. So LFO3, bipolar, pitch. So let's try adjusting the rate. So we can see that down there at 13 is actually very slow. So I might actually speed these up, maybe to 17 and 15. And now I'm going to remove this modulation because it really doesn't make sense for what we're trying to do. But now I have two moving modulation sources, which we can use for modulations here. Now we've heard the rate. LFO4 is a square wave. So an interesting thing about a square wave, actually, I'm going to go with sawtooth and square. The reason I'm going to use sawtooth and square is those waveforms have a jump in them. That discontinuity, when it occurs, is going to make a jump in a parameter that we're modulating. So we have the chorus doing something. Now let's get the reverb doing something. So So I think you can hear when I move the reverb time, we get an interesting sort of pulsing sound happening here. So that's ripe for modulation. Finally, the delay. Let's turn it up. So I'll set the delay time quite short. So we have a short delay here, and when you can hear that adjusting that causes some quite interesting and unusual sounds. So let's go to the modulation matrix now. On the effects section, we have a separate modulation matrix which contains 4 slots distinct from the 16 primary modulation slots. So what was I saying I wanted to modulate? 1 was the reverb time, so let's look at reverb time. 2 was the the delay time. So let's just try setting that. And now let's route these from LFO3 and LFO4. So I'm going to turn up the speed of LFO4 significantly. Let's see what happens if we experiment with a different delay mode. So what I've got here now, instead of modulating the reverb time, I'm modulating the reverb size, which is effectively the size of the room. So what happens if we speed this up? Try a different wave. Okay, so let's experiment with another destination. We can adjust the chorus rate and the chorus depth. So chorus rate, I can adjust if I wish from both LFO3 and LFO4. Let's experiment with chorus feedback. Okay, now let's set the balance. Okay, so what have we done here? Let me bypass the effects. So this is the underlying drone sound. Maybe let me spread the voices a little. So you can hear we have something reasonably interesting, but maybe not very full sounding. And now let's bring the effects in. Remember, when we were looking at the effect configurations, the LFO configurations rather, we have the opportunity to beat sync these. So if this was working with a piece of music, I could have the LFOs be synchronized with the beat, and therefore have this modulation, this kind of pulsing delay that's occurring, and these other modulations occurring in time with the sound. So it wouldn't just be arbitrary motion, it wouldn't be randomized motion, it would be motion that was much more deliberate. So hopefully this has illustrated to you at least the range of possibilities that are opened to you by not only adding effects, not only adding modulations, but in modulating those effects. And as I said, I think this brings this series to a conclusion. What I hope it's illustrated to you is that sound design on subtractive synths is surprisingly similar, irrespective of the synthesizer that you're using. There is a lot of commonality, there is a lot of overlap, and there is a lot of similarity, and the capabilities, though different features may be available, they still cover very similar territory. I hope also I've illustrated that when designing sounds, I use an intellectual understanding of how the signal flows through the synthesizer, of the meaning of each of the controls and how all of the parameters interact with each other. But more than that, I spend a lot of time when designing sounds listening. So in other words, I have an effect that I'm trying to achieve, and then I make changes to try and arrive at that effect. And I think that process of intellectual understanding combined with listening is much more effective than a completely intellectual, scientific approach to patch creation, but it's also much more efficient than a purely aesthetic approach to patch creation where I merely experiment with the knobs. Because, for example, if I was merely experimenting, it's highly unlikely that I would be digging through the oscillator pages to set user waveforms, or digging through the effect section to find those, or to find these global features. So there is a lot to sound design, and I've only covered the basics here, but I hope it's given you a flavor for what's possible. In any case, thank you very much for watching. I hope that you've enjoyed. I hope that you will come back and listen to some other videos that I produce, and I hope that this has been helpful. In any case, thank you and goodbye.